you can express anyway, but it must be there. And if somebody put in just anterior pituitary gland, it's just one small part of the question, because we're looking for conceptual question, because this table helps following question, clinical question to answer. And it looks like there is a correlation. If people missing table, they missing this clinical question, what hormone released from where, how it affects, and what type of disorder. It means it's kind of, it's not like people missing tables accidentally, because if you knew but you did not put, you still use your knowledge for the clinical question. And there is a correlation. If there is no table, there is no answer to the clinical question. But it's just one or two or three people missed it. Mostly everyone doing very well. Okay, anyways, we have Wednesday, today we have Wednesday group, our lab, and next week we have 11 lab. It's 50 points, 25 stations, 2 points each per 1 minute. Yes, please. Oh, yes. I was being driven, what should I do? Post a study guide or finish the exam, and I kind of stayed with the exams. I was curious what's going on. Anyways, today we start a new lab of this course, which will prepare us for the exam 2, lecture exam 2. And the heavy portion of this lab is a cardiovascular. We will be talking about cardiovascular system, about the heart. We have 2 lectures on the heart. And we will be talking about blood vessels. It means this kind of conceptually is very exciting, and if it's excited, it's usually easy to learn. It means cardiovascular system. I would like to start with this diagram, because you cannot talk about the heart unless you completely understand this diagram. And I apologize, it might be overwhelmed slide, but let's go through this and make it easy. It means what we see here, we see the heart, and it's kind of color-coded. It's right part and the left part of the heart. And it turns out that the right part of the heart, people who did already lab and touched the sheep heart, they know that the right part of the heart is not as muscular, is not as kind of large compared to left heart. And for this, it is a very good reason, because the right part of the heart pumping blood only in nearby cardiovascular vascular system to the lungs. It means practically you have one organ, you have the heart, but it's practically 2 different pumps which doing slightly different job, not slightly, tremendously different job. The right part of the heart is the goal to pump the heart to very short and small circulatory system to the lungs in order for the deoxygenated blood to gain oxygen. But the left part of the heart, the big one, the more musculature, they're doing a huge job by pumping blood through the aorta to the entire body. And this is the big difference. It means practically, it's not as a clear diagram, but practically we have the right part of the heart pumping the blood to the nearest lungs. Because if you think about location of the heart, it's just medial to the lungs in the chest cavity. And the left part of the heart, it has all muscles, very strong, very tough. It pumps through the entire body. It means cardiovascular system starts with a pump. And practically in the heart we have two pumps, one smaller pump pumping through the lungs, and the larger pump, left part of the heart, pumping through the rest of the body. Because from here we can see this aorta, which is making branches to provide blood to the head, to the neck, to your brain, and then you have branch of the abdominal aorta, which eventually branches, and coming to each cell in your body through the capillary system, delivering oxygen to the cells. But let me ask you, who is receiver of this oxygen? What part of the cells what parts of intracellular environment they need oxygen, and for what purpose? Somebody thinking mitochondria, right? The mitochondria is a major receiver of the oxygen because mitochondria make an ATP, adenosine triphosphate. It's an energy for the heart, for all the cells' chemical processes. It means all this system with the oxygen coming to the lungs, with the oxygen diffuses into the capillary system in the lung and binding to the what cells binds oxygen in the blood? Hemoglobin inside what the red blood cells. It means all this system of having the lungs, of having this this cardiovascular system, of having the special cells, red blood cells, which pushed out its nuclear because they need more space for the hemoglobin which bind oxygen for only one purpose, to deliver to each cell in your body oxygen which will be consumed by mitochondria in order for mitochondria to make adenosine triphosphate, the major energy for the body. It means what are parts of the cardiovascular system? And I believe it will be a question on the exam. You need to put the heart, the blood vessels, and the blood itself. It's three components in the cardiovascular system. You have your pump, because then we will be talking about lymphatic system. There is no pump in the lymphatic system. It starts from nowhere. It starts from the capillary. In here, in cardiovascular, we have the pump. It means it's a crucial component of cardiovascular system, and it needs means or pipes to deliver blood, and it's a blood vessels, arteries. Usually in the textbook, you have color in red to emphasize oxygenated blood, and the veins usually in blue, kind of to show you that it's slightly deoxygenated blood. It's never the case that the entire oxygen will be taken out. It's quite a high level, 75%. And it never in the body, you'll see different colors. It's just the purpose by convention, how they draw in all textbooks. It means this cardiovascular system using the heart, the blood vessels, and the blood cells transport oxygen to each cell, to its mitochondria. It also transports nutrients to the cells, hormones, and it eliminates cellular waste through the veins. And again, very important point, the cardiovascular system is pumps by the heart. It has a pump. If you take a look where the heart is located, I already mentioned, you need to look at the thoracic cavity, and it's separated by the special pericardial sac to make it kind of less friction and also for cushion protection, and it's kind of in the middle, medium compared to those lungs. It means if you think about the first circle of cardiovascular system, it goes from the right part of the heart, it goes very, very close. The lungs are in the same chest cavity. And all these organs inside the thoracic cavity, as you know, they all covered with a special membrane as a cushion to protect each other and from each other. Now, how the blood goes through the heart. Very important conceptual point. Of course, you know this, I think, but I want to emphasize again. The major rule of the blood to flow through the heart in one direction. It's only one direction, from the right part of the heart to the left part of the heart. And to prevent the backflow, then sometimes you can see in your patients, we have a special sets of the one-way entryway valves. It means our heart made of 4 chambers and 4 valves. And the blood flow from the right part of the heart to the left part of the heart. And then from the left part of the heart to the body. It means what we see here, it's kind of, again, it's diagram. It's more or less remind us on the real heart. Monday people already saw this sheep heart. Wednesday group, you will see it today with the sheep heart. This diagram is pretty much close to what you see on the cross section of the heart. It means here you have your upper chamber, the right atrium. It's the first chamber of the heart is the right atrium. And blood, venous blood, coming to the right atrium, no pump, no valves. It's simply because the blood pressure in the veins is very, very low. It's not 0, it may be 3-5 millimeters of mercury. Compare what you have in the aorta, it's 120 over 80. Yes, please.
What's the difference between atrial and atrium?
It's plural. One atrium is 1 chamber, atria 2. It's Latin. Good question. It means the blood flow through the heart starts in the right atrium. And how the blood gets into the atrium? It's pouring, like passive pouring of the heart from the inferior vena cava vein, from the low part of the body, and superior vena cava from the upper part of the body. But there is no valves here because the reason is no huge pressure difference between these veins and the right atrium, and because of the very, very small volume of the atrium. But the next step for blood to go from the right atrium to the right ventricle is controlled by the first valve on our journey that we just follow of the blood through the heart. It means the first valve, first one-way entryway, first gates that prevents backflow through the heart is in between the atrium and the ventricle. And they call it atrioventricular valve. And it separates atrium from the ventricle. Because after the ventricle is filled during diastole, this valve will be closed because we will be awaiting for the systole. Then the ventricles contract, both ventricles contract. And during contraction, you don't want this blood to be pumped back. You pump in blood into pulmonary trunk or pulmonary arteries, which will bring the blood to the lungs. And again, the second pump, second gate, second one-way entryway you find in between the right ventricle and the pulmonary trunk or pulmonary artery. And this valve has two kind of leaflets, and they call semilunar valve in between the right ventricle and the pulmonary artery. And this blood, it's cut off, will go through the lungs. But if you imagine, probably you don't imagine, but I need to tell it anyways, if you imagine then through the lungs there is a huge, huge pipe with the blood. Because all here is a huge, huge pipes. This is huge size, this size is huge, and then eventually then you go to the lungs. It's not a highway going through the lungs and then returning back to the left part of the heart. It's a system of capillary. And this is the problem, for example, if you have emboli or kind of clot which is traveling often from the deep veins or after surgery from the upper part of the veins. If you have a huge kind of clot, it easily will go here, here, and then it will be stuck in the lungs, because in the lungs we have the capillary system. And you need to treat these patients with a kind of drugs which can dissolve this. And it means here it's cut off, but it goes to the lungs, left, right and left, and then it coming back through the left and right veins. And this blood from the lungs coming into the left atrium. And do you think we have any valves here in between blood flowing from the lungs into the left atrium? No, we don't, because it's very strange. The first confusion which we need to overcome, they call pipes for the deoxygenated blood pulmonary artery, but they draw it in blue color, because blue color always color-coded for deoxygenated venous blood. But because in the minds of the first anatomist, this pulmonary artery brings blood to the lungs, even it's a venous blood. They call it artery. And you draw it, they draw it in the blue color, and you call it artery. And the blood, which is red, already oxygenated blood, a lot of oxygen in this blood, they call it veins, but draw it in the red color. It's kind of one conceptual confusion. But because it's a venous blood, it's pouring without pressure from the circulatory system of the lungs. That is why we have no valves in between the pulmonary veins and the left atrium. And then blood goes into the left ventricle. And again, this atrioventricular valve we have in between the left atrium and the left ventricle. And this is very famous bicuspid valve. We call it mitral valve, because if you have a patient with a heart problem, often we have some prolapse or calcification of the mitral valve, and this is the valve often can be replaced in some patients. It means as soon as blood during systole fills the left ventricle, and left ventricle during systole start contracting, it's sending blood through the aorta, through the aortic valves here, And this is huge, huge aorta. And it shows actually, it's huge. It's the size as your garden hose. It's a huge, huge pipe in your body. And it's a huge aorta. It's sending through the aorta, through the aortic valve, into aorta to distribute it across the body. And I would like to show you a short video just to build up on the blood flow through the heart.
So what you're looking at is one of the most amazing organs in your body. This is the human. One of the most amazing organs in your body. This is the human heart, and it's shown with all the vessels on it, and you can see the vessels coming into it and out of it. But the heart at its core is a pump, and this pump is why we call it the hardest working organ in our body, because it starts pumping blood from the point where you're a little fetus, maybe about 8 weeks old, all the way until the point where you die. And so this organ, I think it would be really cool to look at in a little bit more detail, but it's hard to do that looking just at the outside. So what I did is I actually drew what it might look like on the inside. So let me actually just show you that now, and we'll follow the path of blood through the heart using this diagram. Let me start with a little picture in the corner. So let's say we have a person here, and this is their face, and this is their neck. I'm going to draw their arms. And they have, in the middle of their chest, their heart. And so the whole goal is to make sure that blood from all parts of the body, including their legs, can make its way back to the heart, first of all, and then get pumped back out to the body. So blood is going to come up from this arm, let's say, and dump into there, and the same on this side. And it's going to come from their head. And all three sources, the two arms and the head, are going to come together into one big vein. And that's going to be dumping into the top of the heart. And then separately, you've got veins from the legs, meeting up with veins from the belly, coming into another opening into the heart. So that's how the blood gets back to the heart. And anytime I mention the word...
These openings, those two, are in the right atrium. Both openings from in the superior vena cava and from inferior vena cava, you find in the right atrium, not just general heart.
I just want you to make sure you think of blood going towards the heart. Towards the heart. Now, if blood is going towards the heart, then after the blood is pumped by the heart, it's going to have to go out to the heart, right? It's going to have to go away from the heart. So that's the aorta. And the aorta actually has a little arch like that, and we call it the aortic arch. And it sends off one vessel to the arm, one vessel up this way, a vessel over this way, and then this arch kind of goes down, 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 and splits. Like that. So this is kind of a simplified version of it. But you can see how there are definitely some parallels between how the veins and the arteries are set up. And arteries, so anytime I mention the word artery, I want you to think of blood going away from the heart. And an easy way to remember that is that they both start with the letter A. So going to our big diagram now, we can see that blood coming in this way and blood coming in this way is ending up at the same spot. It's going to end up at the, and actually maybe I'll draw it here, is ending up at the right atrium. Right atrium. That's just the name of the chamber that the blood ends up in. And it came into the right atrium from a giant vessel up top called the superior vena cava. And this is a vein, of course, because it's bringing blood towards the heart. And down here, the inferior vena cava. Inferior vena cava. So these are the two directions that blood is going to be flowing. And once blood is in the right atrium, it's going to head down into the right ventricle. So this is the right ventricle, down here. This is the second chamber of the heart. And it gets there by passing through a valve. And this valve, and all valves in the heart, are basically there to keep blood moving in the right direction. So it doesn't go in the backwards direction. So this valve is called the tricuspid valve. Tricuspid valve. And it's called that because it's basically got 3 little flaps. That's why they call it tri. And I know you can only see 2 in my drawing, and that's just because my drawing is not perfect. And it's hard to show kind of a flap coming out at you, but you can imagine it. So blood goes into the right ventricle, and where does it go next? Well, after that, it's going to go this way. It's going to go into this vessel, and it's going to split. But before it goes there, it has to pass through another valve. So this is a valve right here called a pulmonary valve. Pulmonary valve. And it gives you a clue as to where things are going to go next, right? Because the word pulmonary means lungs. And so if this is my lung on this side, this is my left lung, and this is my right lung on this side, then these vessels, and I'll let you try to guess what they would be called, these vessels, this would be my, make sure I get my right and left straight, this is my left pulmonary artery, and I hesitated there just to make sure you got that because it's taking blood away from the heart, and this is my right pulmonary artery. So this is my right and left pulmonary artery. And so blood goes now into my lungs, right? These are the lungs that are kind of nestled into my thorax where my heart is sitting. Goes into my lungs. And remember, this blood is blue. Why is it blue? Well, it's blue because it doesn't have very much oxygen. And so one thing that I need to pick up is oxygen. And so that's one thing that the lungs are going to help me pick up, and I'm going to write O2 for oxygen. And it's also blue, and that reminds us that it's full of carbon dioxide. It's full of waste because it's coming from the body, right? And the body's made a lot of carbon dioxide that it's trying to get rid of. So in the lungs, you get rid of your carbon dioxide and you pick up oxygen. So that's why I switch at this point from a blue-colored vessel to a red-colored vessel. So now blood comes back in this way, and dumps into this chamber. So what is that? This is our left atrium. Our left atrium. So just like our right atrium, we have one on the left. And it goes down into, and you can probably guess what this one is called, it's our left ventricle. So just like before, where it went from the right atrium to the right ventricle, now we're going from the left atrium to the left ventricle. And it passes through a valve here, right? So this valve is called the mitral valve. Mitral valve. And its job is, of course, to make sure that blood does not go from the left ventricle back to the left atrium by accident. It wants to make sure that there's forward flow. And then the final valve, and I have to find a nice spot to write it, maybe right here, this final valve that it passes through is called the aortic valve. Aortic valve. And the aortic valve is going to be what divides the left ventricle from this giant vessel that we talked about earlier. And this is, of course, the aorta. This is my aorta. So now blood is going to go through the aorta to the rest of the body. So you can see how blood now flows from the body into the 4 chambers. First into the right atrium, this is chamber number 1. And then it goes into the right ventricle, this is chamber number 2. It goes to the lungs and then back out to the left atrium, so this is chamber number 3, and then the left ventricle. And this happens every moment of every day. Every time you hear your heart beating, this process is going on. So what you're looking at is one of the most amazing.
You have these links, it means you always can look and have more very important links. It means we just learned very important concept of the cardiovascular system, very important concept on the blood flow through the heart. We learned that we have 4 chambers, 4 valves, and we also learned the names of the major vessels which bring in blood to the heart and taking blood away from the heart. We also learned about location of the heart, and kind of, we just talk on this diagram, which we just kind of even learn more through these short videos. And now we know, if, for example, I ask you to write like a small sentence for me, how the blood flows, you do exactly what we have here. Blood comes from the tissue, and through the superior and inferior vena cava, it pours, it delivers blood into the right atrium. And then through tricuspid valve, it's atrioventricular valve, another name for this valve. Tricuspid simply the only valve with 3 leaflets. And then from the tricuspid valve, it goes to the right ventricle. It's one direction. It will be on the exam. You need to kind of draw this directional flow. Or I believe it will be multiple choices you will choose. And then from the right ventricle into pulmonary semilunar valve, into pulmonary artery, to the lungs, from the lungs, and through the pulmonary veins to the left atrium, and then through the mitral bicuspid valve to the left ventricle, and then through the aortic semilunar valve to aorta and to the whole body tissue. This is concept we just learned, and we learned the names of the valves and the names of the chambers. And here there is another representation. If I ask you, for example, where is the tricuspid valve on this diagram? This one, the big one, right? Where is the pulmonary semilunar valve? Top. On the top, mitral bicuspid valve, for another huge one, and the last one, aortic semilunar. No, it means, this kind of almost like three-dimensional, it means you have very, very good kind of concept of this location of the valves, location of the chamber, and also a very important concept of the directional flow of the blood through the heart. And this is, we need to emphasize, in addition, what we need to learn today, not only names of the chambers of the heart, the valves, we also need to learn the name of the major vessels, which bring in blood to the heart. Superior vena cava coming from the top of your body. Inferior vena cava from the bottom part of your body. Pulmonary trunk or pulmonary arteries, and then pulmonary vein bringing blood to the lungs, and from the lungs to the heart, and then through the aorta, the major huge vessel. We will talk about a lot